Dear members of the International Society of Condensed Matter Nuclear Science, in 2024 I promised you a book about LENR to achieve public acclaim for the International Society of Condensed Matter Nuclear Science, a project PR, so to speak. I had to postpone publication though because of my insight in this subject of PP fusion in LENR. I do not want to present you with a fait accompli. I first have to tell you about it. We with LENR are involved in a paradigmatic revolution. We need to look at things differently. Thomas Kuhn, philosopher of science, said in his book The Structure of Scientific Revolutions, to reject one paradigm without simultaneously substituting another is to reject science itself, and added, truth emerges more readily from error than from confusion. Considering the fusion-confusion about LENR, we hence must, first of all, offer an acceptable alternative, and second, discover the error that prevented the bridge in words we need to reach the global community. Contents. I will discuss the quasi-fusion definition, its mechanism, what it does in the Sun and in LENR, the different theories, the PPP version, how it compares, and a LENR theorem. What is quasi-fusion? It is the third process of nuclear energy production next to fusion and fission. It is nuclear synthesis, resulting from radiative N-capture, E-capture, beta decay, and quasi-particle-assisted weak nuclear transformations or QUANT, isotopic shifts and transmutations. So we have hot fusion and B, quasi-fusion. Hot fusion with the strong nuclear force faces the Coulomb barrier and requires tunneling. Quasi-fusion with predominantly the weak nuclear force faces the creation of a stable lepton-hadron conversion loop, a LHCl. Quasi-fusion not only means the quasi-particle effects of decay and capture, LECR, but also an appearance of fusion when in fact we are just synthesizing nuclei. To the left, you see standard PP fusion in the Sun first creates a deuteron which captures a proton so as to fuse helium-3 into helium-4. At the right, we in PP quasi-fusion in phase 1 create a neutron to synthesize a deuteron, eventually leading to tritium and helium. Phase 2 involves a so-called deuterium quasiparticle of energized deuterium, eventually synthesizing helium-4. Since 1991, several authors also found LENR with normal water, which gave theoretical problems with, first of all, insufficient nuclear byproducts and, second of all, neutronization as the theoretical bottleneck. How can LENR overcome a mass energy barrier of 0.782 mega electron volts? And then there is the reproach. LENR appears as unrealistic or bad science, with even talk of good and bad LENR. The LHCl mechanism explains this. It is an oscillating subatomic coherence of mutually reinforcing hadrons, protons and neutrons, and leptons, electrons and positrons, offering two ways to produce neutrons, beta plus decay and E-capture. Left you see Lev Landau, who in 1930 proposed to speak of quasiparticles, and Carl Anderson, Wright, in 1936 explained the interaction of leptons as relating to gamma. Cook and Dalla Casa 2014 stated that the dogmatic denial in physics of a lepton influence on the hadrons, and thus of a LHCl, is overruled by LENR evidence. While in the Sun, neutron production by this loop is rare, in LENR putting the Sun in a bottle, this LHCl loop works. The question is, how and why? A LHCl quasiparticle may oscillate because of the nature of its constituent parts. These parts were described in the 1950s by Ernest Sternglass and in 1926 by Andreas von Antropov. Sternglass, being mentored by Richard Feynman at Cornell, after seeing neutrons in a Röntgen tube, consulted Einstein and concluded to a semi-stable electron-positron coherence, a kind of cosmic seed called positronium since 1951. Antropov offered a periodic table headed by a so-called zero-element particle. It is a short-lived quasi-particle called neutronium, in LENR known as a dineutron. Because of the anomalous heat effect, one may wonder whether the positron-neutronium coherence, light green, pink, of a LHCl constitutes a gate for the conversion of subatomic mass energy alone. LHCl viability. George Edgley, chief engineer at NG8, created a table showing the economic prospects for having nuclear energy with the two methods of quasifusion and standard fusion. The economic viability looks bleak for the blue frame of hot fusion. It might work for the LENR hot lattice oscillation though, in the fourth orange column, but a self-sufficient, energy-efficient loop can be achieved for certain with dusty plasmas and quasi-particles, according to Edgley. Quasifusion nuclear hydrogen reactions may be divided in those based on the strong nuclear force, in red, and the ones of the weak nuclear force, in green. The red LENR reactions concern the strong 2 of DD deuterium fusion facing the Coulomb barrier, and 2 radiative N-capture reactions. N-capture is quasi-fusion resulting in heavier isotopes, deuterium and tritium, and gamma radiation. In green, one sees the quasi-fusion reactions of E-capture and beta decay. They demand energy input because of the mass-energy barrier. The orange third category marks the second phase of quasi-fusion reactions, the quant, quasi-particle assisted weak nuclear transformations of energized deuterium or deuterions. They produce dineutrons, helium, heavier isotopes and transmutations, as found in many LENR experiments. The LECR or capture reactions are the reactions in the blue box. Many LENR phenomena can be explained on the basis of these. The data are derived from experiments by, for instance, Storms, Edgley, Geithner, Matsumoto, Wiedemann and Larson, Goetz, Mitsuno and Iwamura. In the PP fusion of the Sun, one proton must neutronize in order to fuse, but in fact it is by beta plus decay synthesizing a deuteron in quasifusion. This deuteron synthesis, or quark flipping, see Feynman diagram, proceeds in 2 steps. Step 1. One proton undergoes beta plus decay and produces a neutron, a positron, and an electron neutrino. The energy cost is equal to the mass difference of the mass energy of the proton plus the mass energy of the electron minus the mass energy of the neutron, or 0.782 mega electron volts. The process is rare in the Sun. The experimental cross-section is practically nil. Step 2. That neutron is captured by the second proton. It is a 2-body process yielding a deuteron, neutrino and 1.422 mega electron volts unrecoverable, that is to say not convertible, gamma, of which 1.022 mega electron volts is turned into light and heat. It's rare in the Sun. It has an experimental cross-section of 0. The positron rule demands a sufficient mass-energy difference. It means that the difference between the mass of the parent proton and the one of the fed daughter deuteron has to exceed 1.022 mega electron volts in order to produce a positron. PP reactions in LENR. Wiedom-Larsen offers the capture of a heavy electron yielding 1.442 mega electron volts gamma, a deuteron and a neutrino. No positron or recoverable annihilation gamma is released, nor a free neutron for LENR tritium. The challenge here is formed by the 0.782 mega electron volts E-capture demand. Considering these PP problems, these reactions in general are disconsidered. However, what applies to the Sun does not yet apply to the alternative nuclear process of LENR quasifusion. The founders of LENR theory, Preparata, Fleischmann and Pons, defend quasifusion as a coherent quantum electrodynamic phenomenon. See QED. Fleischmann confessed to Stephen Crivet that he regretted ever having referred to it as fusion. Their stance is, for a feasible LENR theory, there must be a multi-body reaction of 3 or more subatomic particles. The Brazilians Balduino et al. Demonstrated this in 2022 based on 30 years of LENR experiments. Many LENR theory authors, mentioned here as also others from Italy, Russia, France, China and India, declared LENR as indeed based on the dynamics of multibody effects. The basic reaction chain of quasifusion must be a reaction with at least 3 particles. What happens then? When we, with 3 protons, LHCl, attract an ambient electron and capture a heavy electron, this 3p plus 2e input results in a deuteron, a free neutron, 2 electron neutrinos, and gamma. It is a 3-step process. The annihilation gamma can be converted, can be recovered by LENR confinement and thus increases the quasifusion cross-section. It is because the positron rule allows this positron formation and annihilation for a non-linear multi-body reaction. This is essentially the beta protocol. Step 1. Beta plus decay of a proton yields, with a 1 to 2 mega electron volts threshold value, a neutron, an electron neutrino, and delivers 1.022 MeV gamma. This quasi-fusion proton decay does not happen spontaneously. The multibody transition requires specific condensed matter conditions. In step 2, it takes about 0.8 MeV for a heavy electron to produce a bound neutron. Step 1 and step 2 taken together then deliver a Qn of 1.022 minus 0.782 MeV, which makes 0.24 MeV. This hybrid neutron generation of coupled channels is exergonic only because they lead to deuteron formation. It is the positron rule. In step 3, a deuteron forms with the third proton and bound neutron. This, as a standard, delivers a QD of 2.224 MeV pure energy gain in gamma. These 3 steps of the quasi-fusion PPP reaction happen at the same time in parallel. They do not follow a linear logic. The quasi-fusion PPP net gain QQ consists of the net gain of step 2 plus the net gain of step 3, which is 0.24 plus 2.224 is 2.464 MeV. And this quasi-fusion PPP reaction is a bookkeeping framework consistent with observed anomalies. We have a likewise net result of the IQ, the QS of Fleischmann and Pons. In 1989, they thought to measure the gamma of neutrons in water, but that was not correct, for it produces 2.2 MeV, not 2.5 MeV. Their mistake was to think they had made a mistake, like Einstein with lambda. This 2.5 MeV we see now in a different light. It is a LHCl quasi-particle result. Sometimes quasi-fusion produces such a value, but of course, much more can happen with that gamma. LHCl gamma processing, for instance, implies that normal hydrogen may give a likewise result as heavy hydrogen. Also because of this quasi-fusion looping, a self-sustaining reaction is possible. What matters are the preconditions. This table compares solar fusion yellow, quasi-fusion green and Wiedemann-Larsen E-capture in red. When are there electrons on the left-hand side, LHS, and positrons on the right-hand side of the reaction arrow? How much energy goes in, where does it go, and what is the key description? As opposed to Wiedemann-Larsen, PPP hybrid neutronization explains the quasi-particle and condensed plasmoid reactions of quant. This LENR elephant in the room of the big time as a cause-tac picture is hard to discern, but the PPP perspective now clarifies matters and answers questions. The conservation rules for lepton number, charge, energy, baryon number and momentum are respected. The quasi-fusion second phase is ruled by quant, weak force nuclear transformations assisted by quasi-particles and condensed plasmoids named deuterium, dineutron and zero element. The COP for the PPP process is 1.36. PPPT for tritium, it is 4.8. As for the LHCl vacuum concern, we can say, since chemical and nuclear energy do not fully explain the excess heat, for a full explanation there is possibly no other option but the vacuum hypothesis. It is not just mass energy conversion. So we need a LENR theorem. Preparata, Vysotsky and others emphasize collective quantum coherence and multibody coupling as a cause of LENR, but do not refer to fluctuations of the quantum vacuum, zero-point field, as a cause of excess energy. Thus, there are the mainstream LENR models who are not that explicit about the vacuum option, and those who are more pronounced, like those of Scholz, Matsumoto, Heisch, Rueda and Puthoff, Kozyrev, Shipov, and more ZPE defenders. Zero-point energy suffers the problem of lacking unique byproducts, of possible alternative channels, and of skepticism. A theorem can appease the models. For an inclusive LENR approach, we have to integrate two explanatory routes. 1. The mainstream path of quasifusion, in which normal excess energy is not explained by chemical sources. 2. The second path of vacuum energy conversion, in which true excess energy is explained by neither chemical nor nuclear sources. True excess energy, ET, as such, concerns the sum of subatomic mass conversion energy, ES, chemical process energy, EC, and the energy of vacuum-driven quasiparticle interactions, EQP. This leads to the following theorem. ET equals ES plus EC plus EQP. In words, true excess energy is a composite of nuclear, chemical and vacuum-sourced quasiparticle energy. Can one refute this, according to Popper, conjectures and refutations? This implies one cannot exclude the vacuum option as a source without providing a complete explanation of all excess energy. All will agree. This reveals exclusion as the original error preventing the bridge of our own inclusion. We can now discuss these conclusions. The first one. The LENR process of quasifusion is based on quasiparticle-induced nuclear synthesis, the formation of atomic nuclei by beta decay and low-energy capture reactions, LECR. 2. The QQ value for the first PPP phase of deuteron synthesis is 1.7 times higher than the PP E-capture assumption. 3. The PPP production of two neutrons, one bound, one free, is hexagonic. 4. Production of excess energy in LENR does not depend on the formation of transmutations or heavier isotopes. 5. In quasifusion, there is always an interaction between leptons, electrons and positrons, and hadrons, neutrons and protons, which together may form a loop of mutually reinforcing reactions, LHCl. 6. LENR excess energy is fundamentally based on known nuclear processes free from the Coulomb barrier. 7. Exotic processes of weak force-ruled nuclear transformations may occur which, with transmutations, oscillations and other quasiparticle and condensed plasmoid nuclear effects, may contribute to the energy excess. Quant. There is 1 to 10 strong evidence for the vacuum hypothesis. There is no refutation of ET is equal to En plus EC plus EQP. From this follows the CTTS. 9. True excess energy is free energy not explained by nuclear or chemical processes alone. The LENR theorem. 10. A PPP coherent process of quasi-fusion meeting the LHCl requirements may sustain itself. 11. LENR works with both protium and deuterium because of the LHCl chain of electron processing. 12. The CTTS paradigm implies a shift from nuclear synthesis by fugacity or plasma control to a conversion of vacuum energy. So finally, quasi-fusion allows one to see what one does not understand. I thank you for your attention.